The Atlas, mysterious comet of 2025. In every era, the sky offers us signs. Some go unnoticed. Others force us to look beyond what we think we know. 3I Atlas, a comet, a message, or just a cosmic coincidence? In recent months, it has defied the astral rules. It approached Mars, projected a tail towards the sun, and raised questions that even science does not yet have answers to. Today, on the Decoding the Unknown channel, we continue to decode the unknown and discover what is hidden in the silence between the stars. Hook and context. Atlas is not just another comet. In recent weeks, observations and analyses have painted a strange portrait, a large, fast-moving interstellar object, atypical in almost every important respect. On October 3rd, it passed closest to Mars, and in the days that followed, it disappeared into solar conjunction, just before reaching its closest approach to the Sun on October 29, 2025. A timing that, for many, raises eyebrows. 7 Anomalies explained simply. In short, here is the set of questions that make 3I Atlas a special case. 1. Size. Minimum estimated diameter exceeds 5 kilometers. Mass over 33 billion tons, far larger than 1I Oumuamua and 2I Borisov. 2. Jet towards the sun, anti-tail. Hubble captured a narrow extension pointing towards the sun, not in the opposite direction, as we usually see in comets. 3. Composition. Instead of water dominating, the observed gas indicates CO2, carbon dioxide, as the main component. The gas spectrum shows prominent nickel, with no iron, an unusual ratio compared to known comets. 4. Polarization. Light with extreme negative polarization, rare for comets. 5. Orbit. The orbital plane is aligned with the ecliptic at approximately 5 degrees, an alignment that seems unlikely to have occurred by chance. 6. Calendar. Relatively close passes by Mars, Venus, and Jupiter in a tight time window. 7. Direction of arrival. Close to the direction of the famous WOW signal, a powerful narrowband radio signal of unknown origin detected by the Big Ear radio telescope on August 15, 1977, which has become one of the most famous and intriguing mysteries in the search for extraterrestrial life. All of them, on their own, do not prove anything extraordinary, but they keep the 3I Atlas case in the out-of-print zone. Planes, chances, and geometry. Why do astronomers keep insisting on that figure of about 5 degrees? Because the entry almost sticking to the plane of the ecliptic, combined with the well-timed passages of the planet's orbits, has a low probability if you draw it by chance. That doesn't mean it has to be artificial, but it does mean it's worth watching more closely. In a material from October 5, it is shown why a small angle to the ecliptic can still be expected if a hypothetical civilization discovered us by transit methods. You aim in the plane, where the planets actually pass in front of the sun. What the Mars probe saw and didn't see. On October 7th, ESA, European Space Agency, released the first images from the ExoMars TGO, Trace Gas Orbiter. 3I Atlas appears as a diffuse smudge, exactly as the instrument's resolution at 30 million kilometers allows. Mars Express, the first European space probe sent to Mars, did not have enough exposure for clear detection. Everyone was waiting for the high-rise, high-resolution images from the MRO, Mars Reconnaissance Orbiter, NASA's spacecraft launched in 2005, which reached Mars's orbit in 2006, which would get down to about 30 kilometers per pixel on the brightest region, enough to improve the constraint on the core diameter. By October 23rd, we didn't have those high-rise images publicly available. From what was published, there was no sign of any major flare since the summer. Jet to the Sun, TTT confirms the theme. A recent article cites an image taken on August 2, 2025 by the 2-meter twin telescope, TTT, in the Canary Islands. A faint jet, aligned towards the Sun, about 6,000 projected kilometers. The anti-tail remains the favorite oddity of the 3I Atlas case, because normally the dust is pushed away from the Sun by the pressure of light. Here, the signature does not look like a classic dust cloud with a tail, and the standard explanations with perspective illusions, so-called false anti-tails, do not fit the geometry at hand. Nickel, cyanide, and very little water. A new data set from Keck Cosmic Web Imager, a spectrograph astronomical instrument installed on the 10-meter Keck 2 telescope, on the August 24, 2025 observation shows strong nickel and cyanide emissions, with nickel concentrated more centrally, but no iron detected, atypical for comets. And other sets show that about 87% of the lost gas mass is carbon dioxide, about 9% is carbon monoxide, and only about 4% is water. This puts 3I Atlas outside the median for comets and reinforces the idea that it is not a regular visitor. How strongly is 3I Atlas bound, and could it break apart? From current estimates, the release speed from the surface is small, meters per second depending on the diameter, and the rotation period of about 16.16 hours is not enough alone to gravitationally break it if we are talking about a classic cometary nucleus. However, the heating at perihelion can generate thermal stress, irregular jets, and in some cases, fragmentation, exactly what has been seen historically in other comets. On October 10th, Loeb asks directly, "Will 3I Atlas break up?" The honest answer, we don't know yet. After October 29th, we will see in ground-based images, November, December, and possibly from JUICE in November if fragments or, on the contrary, mini-probes, technological hypothesis, appear. But this remains speculative until we have evidence. Solar conjunction and the blind window. On October 21, 2025, 3I Atlas entered solar conjunction. At this rare moment, the Sun is exactly between Earth and the interstellar object, completely obscuring it from view. It is a perfect alignment, but also a temporary separation, a time when humanity's eyes go, for a short time, blind. Astronomers call this period the blind window, when the Sun's light is so intense that it overshadows all other light. Neither telescopes can look, nor the Juno probe can send back images. Everything enters a forced silence of observation, a cosmic pause. But even in this absence, the mystery does not disappear. It just waits beyond the Sun, unseen, until it reappears, perhaps changed, perhaps closer to the truth. Today, on October 29th, in just 8 days, it reaches perihelion, approximately 203 million kilometers. For those who love technical scenarios, this is the most effective moment for Oberth-type maneuvers, if, I repeat, if there were a technological platform. For us, the useful part is different. After the conjunction, we will be able to testably look for changes, new objects, or fragments that break up into slightly different orbits. This is where science can confirm or disprove hypotheses. What remains to be asked? Long-term lessons. At the end of this stage, the question is no longer just what 3I Atlas is, but what it tells us about ourselves. The interstellar object has sparked not only curiosity, but also reflection. Beyond the numbers and trajectories, a larger theme remains: how we react when the unknown stares back at us. In a Q&A published on October 8th, Loeb emphasized the real stakes. Not just the discovery of a new cosmic visitor, but our ability to understand it without prejudice. If we don't observe, we'll never know, he said. Science isn't just about having answers, it's about asking the right questions and having the courage to pursue them no matter how uncomfortable they may be. As 3i Atlas passes beyond the sun, leaving behind a trail of light and silence, something deeper than its physical mystery remains: the lesson that every unknown object forces us to look beyond our own limits, not just of technology, but of imagination. Because sometimes the most important thing an interstellar journey brings us is not the answer, but the realization of how little we know about what surrounds us. In the universe, every answer opens a new question, and 3i Atlas is no exception. Maybe it's just a comet with unusual features, or maybe it's proof that we're not alone. It remains to look at the sky with the same curiosity that has always made us wonder where we came from and who's looking back at us. If you want to be among those who seek the truth beyond appearances, subscribe to Decoding the Unknown and let your mind fly beyond the frontiers of science. Until the next episode, look at the sky. The mysteries are just beginning.